Hello, fellow Haskellers, and welcome to the season finale of Giggles is You. So yeah, we've had the season finale of Haskell Mask last weekend, and I'm doing the season finale of Giggles is You right now. I'm closing off all of my streams because I expect it to be very busy soonish, and so I do plan to have like another season of something. I probably not for Giggles is You. Like I think the project is far enough along. I'll probably start a different project for season 2. But I can't tell you like when season 2 is going to be, because I'm going to be busy for a while, and I don't know when I'll be available. In any case, let's do the current episode. I have, like last time, already implemented the feature that I want to talk about, so that I can talk to you about it during a shorter amount of time than when I was implementing the feature live. So here is the feature that I want to talk about. The feature I have implemented is the on keyword here. And so the sentence here says, sheets on Giggle is you. And there are two rules in there. There is Giggle is you, that is a separate rule which allows my character to move. And there is sheets on Giggles is you. And the way in which my parser works, like all of the sentences that can be constructed using a consecutive subset of words apply. And so both Giggles is you and sheets on Giggles is you are two rules which apply. So Giggles is you, I can move. Sheets, this character, would be me if it was on Giggles. So I would be able to control sheets if it was on the red character Giggles. Here, it's the opposite. Giggles is on sheets, so that doesn't work. Sheets isn't moving. But I can make it happen differently. So if I say sheets is you and I move all the way over here, now sheets has moved on top of Giggles. Now I can still move both because sheets is you and Giggles is you are both enabled. But if I disable sheets is you, then now I can still move despite the fact that the sheets is you rule is no longer applying, and that's because the sheets on Giggles is you rule is applying. So if for example, I intentionally break this rule, then now I can only move Giggles and not sheets. Okay, so the reason I wanted to implement this rule is because, as I've explained several times already, the inspiration for this presentation, for this season, for this show, is that I wanted to show that with Haskell, implementing like a parser for this kind of rule is not too bad, whereas the original author made a video claiming that the way in which they implemented the parser was needed to special case the rules of length 3 and the rules of length 5. I think they got better since, but that was the inspiration. In any case, so I wanted to show you how I implemented this feature. And, well, I implemented it in two different ways, not because I intended to show you two different ways, but because I implemented it in the poor way first, and then I suffered the consequences, and so I decided to re-implement it in a better way in order to, well, just because when I see an opportunity to improve the code and make it less error prone, I take it, and I think it might be a good opportunity to compare and contrast what those two approaches are, and whether we indeed have fewer bugs when we use the less error-prone approach. So let me go a few commits back in time so I can show you that version. So in the last episode, we did this, right? Parsing a non-deterministic input in a performant way. That was cool. But next, we're moving on, back to trying to implement the on keyword. So what did I do here? Wrap name in subject. So the idea here is that we used to have rules. Subject is push, subject is stop, not subject. We used to have name is push, name is stop, name is you. And so in all three cases, it was a particular object, for example, Giggles, that when this rule was enabled could now move when we type the keys. And now I want to allow more general sentences instead of just something like a single word, a single name is you. And I want to enable a more complex sentence like sheets on Giggles is you. So sheets on Giggles is the subject of the sentence, the thing that is you. And so that's why I've generalized these three constructors from taking a name to taking a subject. And what is a subject? Well, it's either Giggles, either something that Giggles, so either a name, or a compound like sheets on Giggles. And that already raises a question. So, okay, well, if I can have a bigger construct with a name on and another name, but wait, we just said that we used to have a name and we generalized it to an arbitrary subject. So, like, can I nest those? Can I have like a subject on another subject? And I decided that this would be too much. Like if I have A on B on C on D, then this, like remember, like I'm recognizing all of the rules that can be parsed, and there would be way too many. There would be the parenthesization A on B on C. There would be the parenthesization A on B on C on D, and A on B on D on C, and so on. There's all the possible parenthesization. And in the end, like, on is like an associative operator, like, I think. So it doesn't really matter how you rearrange the parentheses. And so I decided that the subject, oh, well, I haven't implemented that in, in this commit, so let's look at the commit that comes after it. Okay, so yeah, a subject consists of either a name or a name and a subject. So I choose the right biased parenthesization. If I have A on B on C, I enter that as A on B on C. Okay, so how do I parse that? It's as trivial as I had expected, because we have the power of well, early and all of the other parser libraries in Haskell allow us to describe what we want to parse just as a grammar. So it's pretty easy to state that a subject is either a name with the name subject constructor, or that other constructor name on subject, in which case we need both a name, the word on, and the subject. Easy enough. And I guess I picked the least impressive parenthesization. If I had picked the left biased parenthesization instead of the right biased parenthesization, then my grammar would be left recursive, and that would have been a nice opportunity to demonstrate that early supports those, because in many parser combinator libraries in Haskell, you can write it, it type checks, but then it loops at runtime. You don't get a parser. Okay, so that's this commit. There's a test, yeah, that's pretty much it. What else did I do after that? And is it something I want to show? Split rules into subject and adjective, yes. So I have shown you the rules called name name is push, now called subject is push, and now that I had to write the associated code, not for parsing was trivial as you just saw, but like the code in like to interpret the rules, like when we are trying to determine, okay, when I press a key, like which characters move and like are they stopped by the things that are stopped and things like that. Well, I need to like check, okay, is this entity stop or is this entity you, and so on. And well, so far there were only 3. Like I had a little bit of code duplication in order to detect whether something was you, or and that was duplicated with the code to check if something was push, because like there's no way to abstract over the constructor name is you and the constructor name is push, or rather there was. Like I guess I should show you what I did right before I changed it. Like I had this abstraction over like which of those 3 constructors, for which I was representing the constructor as a function, because every constructor is a function. And it just so happened that since the way in which, like the old code in red here, was checking whether a rule was active, like whether a particular name was you, is that I constructed the corresponding rules. If I want to know if Giggles is you, I construct the rule, name is you, Giggles, and then I checked if the rule I had constructed it was a member of the list of rules. It doesn't look exactly like that right now because I renamed it to include subjects and things like that, but that was the basic idea. But I can't do that anymore. Now that Giggles may or may not be you, depending on whether it is on something else. In the example before, Sheets may or may not be you, depending on whether it is on top of Giggles. I say on top of, like the way in which I interpret that is like somewhere above. Like if you have a stack of several entities, as long as A is somewhere above B in the stack, like there can be some other entities in between, then I consider it to be to apply, like to be you if the rule is Sheets on Giggles is you. Anyway, so yeah, I can't just construct the rule Giggles is you, because, well, maybe the rule is not, the rule Giggles is you is not in the set of rules. I mean, Sheets is you. If I want to know if Sheets is you, I cannot just check if Sheets is you is in the rules. Because it could be that the reason why Sheets is you is that Sheets on Giggles is you, and the particular instance of Sheets that I'm talking about is on top of Giggles. And so that means that in order to know whether a particular entity is you or not, I need a lot more information. I need to know what are the things on top of which it is are. I need to know on top of what it is. And also I can't construct a rule. So that's why here I have this more complex implementation. What is this one? Well, it's not yet the more complex implementation. It's a step towards the more complex implementation, in which instead of constructing the rule, because I can no longer abstract over whether I mean is you, is push, or is stop, using the constructor name is you, name is push, name is stop. Instead, I now split the definition of my rules. Here, a rule always has the form subject is something. The something can be push, you, or stop, and the subject we've already seen. So that will allow me to abstract over the 3 different adjectives that a thing can be. That's what I did in that commit. And what's next? All right, so that is the implementation I want to show. Okay, so a stack is just a list of entities, but like, like since I care about the things that are underneath, it makes a lot of sense to sort that list of entities from top to bottom, so that like when I recur over that list, I can look at the rest of the list in order to check, in order to get all of the things that are underneath the current entity. Like I wrote a lot of code like using that assumption in mind until I thought, okay, well maybe it would be a good idea to change the implementation of level array so that it stores stacks instead of storing lists of entities. And then I realized that I used FSF convention there, just because of the way in which my pretty printer for levels was working. If you remember, I have a level in scope. I have only one level. I call it level 1. I haven't implemented the logic to like win the level and move on to the next level. I don't think that's the most important part, because I'm not trying to make a game you can play, just a prototype, a demonstration that it's feasible. So I have a level, but I can't show it to you because there's no show instance. But like even if I could, a level consists of an array and like a list that we did not end up using for anything. I was planning to make the animation smoother, but we never got around to it. It is possible, I think with force, to pretty print the level anyway, but like it's not at all clear like what is the shape of that level. We know like, okay, there's the text U like at position 0, 2, but like it's not very visual, and so that's why I wrote a pretty printer for level 1, and well, it still doesn't look very readable, but it returns a list of strings which I can print one on each line, and now it looks like something. It looks like the same level where we have lowercase GIY for Giggles is U, and TIP for text is push, and HIY for sheets is U. Like S is already used for stop, so H is for sheets, and a capital H for the sheets character rather than the word sheet, and a capital G for the Giggles character rather than the word Giggles. Why was I telling you about my pretty printer? I forget. Right, I remember. It's because on this line, for the needs of my pretty printer, it was just more convenient to store the entities from bottom to top. So there are some assumptions in the code that does the pretty printing that assumes that they are sorted in that order, and I now accidentally wrote some code with the opposite assumption. So that means that whenever I want to convert from that kind of list entity to that kind of list entity, then I have to call reverse in order to do the conversion. And well, you might already guess that this is the poor approach to implementing this that I alluded to at the beginning of the video, because we have, like, this is very error prone, right? I'm using a type synonym for a list of entity, and then this other list of entity is like, it has the same representation, it's the same type, and so the compiler will not warn me when I'm using this kind of list of entity in a function that expects a stack, and so I won't have the opportunity to be reminded that I need to call reverse. Okay, so nevertheless, I carried on with that abstraction, a stack. So lower in this function, I have the entities at, no? Stack at? Sprites at. I had the sprites at function that was returning that list of entities from bottom to top. And now I've added a stack at function with basically the same type signature, and I just need to remember to call stack at when I want the version that is sorted from top to bottom, and sprite at when I want the other one. So here's how I used that in rules in order to try and recognize like which character should move when. So if we look at move you, the function we looked at many times throughout the season, we're constructing chunks, and we're doing so here by going through all of the cells and grouping them into chunks, and then either saying that the whole chunk is moving if there is a thing that is you that is pushing the things that are push, and there is nothing that is stuck preventing it from moving, and otherwise abandoning the chunk. And so that requires checking whether at a particular cell there is something that is you, and whether there's something that is push, and whether there's something that is stop. And for complicated reason that we covered in previous episodes, it is also necessary to determine whether there is a single entity, a single sprite on the stack that is simultaneously like a combination of two things. I don't remember which combinations it was. It's stop but not you. And the reason for that is that if it's you, then it will have moved away, and so we don't care the fact that it is stuck. It will not prevent other things from moving on top of the cell because it won't be there blocking. And similarly for things that are stop but not push, let's see if I remember why. Because if a thing is stop but it is push, then it's fine for me to push it to the next cell. It is not preventing the chunk from moving. So those are the two combinations that I need, and I also naturally need to check if something is you and if something is stop, or if something is push. So all of those combinations were pretty easy before, because I could just look at each of the entity in each cell and ask for each entity, are you push, or you stop, using the function I showed earlier, where I construct the corresponding rule. If I want to know if Giggles is you and not stop, I check if Giggles is you is in the set of rules, but Giggles is stop not on the set of rules. But now that's more complicated, right? Because I need to know what's underneath. And so what I did for has, none, you, stops, for example, they're all the same. Let's look at this one. So stack at, right? I'm getting it from top to bottom, not from bottom to top. And then I'm calling tails, and that is because I want to investigate each element in the stack, one after the other, each sprite. And for each of them, I care about what is afterwards. So if I go back in the REPL, like A, B, and C, they're my top three, or let's say like Giggles is, Sheets is on top of Giggles, which is on top of piece of text, whatever the text is. And then if I call tails, I can take from the top of list, then I get S and the things that are underneath it, so that I can investigate sheets, and I get Giggles and the things that are underneath it, so that I can investigate Giggles, and I can also investigate the word is that is not on top of anything else. And also an empty list for some reason. That will come back and bite us. Spoilers. Okay, yeah, so that's why I'm calling tails. I'm constructing all of the lists of the thing I care about and the things that are underneath it, and I ask if for any of those lists of the thing I care about and the things underneath it, stack has none you step on that. It's true. So that complicated function, like I have a bunch. I have like an on top version. I have a non on top version. I have a version with non push step and a version with non use step. I have a bunch. But again, let's just focus on one of them. So I'm calling stack has stop on top. Right, because what I want to know is for a given stack, right, the thing I care about and the thing underneath it, if the item that is on top, that is the element that I'm investigating, is stop but is not you, right? And so I can do that by looking at the thing on top and asking if it is stop, if the stack has an item that is stop on top, and if the stack has a thing that is you on top, and then negating the answer. So that gives me the answer for whether there is something that is stop and not you. Okay, so lots of code duplication here. But there was even more before, because this stack has stop. Like I used to have a stack has stop on top and stack has stop anywhere. I guess the name of the function we were just looking at, stack has none you stop on top, is a remnant of that convention. But now, there was way too much duplication, so that's why I abstracted away from the differences, and I created this expected location data type right here that is either the word on top or anywhere. So far we've only looked at on top because the thing of interest was the first element of my list, the thing we care about and the things it is on top of. But in order to know whether that thing is you, for example, then I need to worry about the rules of the form. Sheets on Giggles is you, right? And so, where was I? Yeah, this stack has you delegates to stack has adjective, because yeah, right. The reason as I explained earlier, that I split the objectives separately was so that I could do this refactoring, so that there wouldn't be too much duplication. We can talk about the adjectives separately. And so now, instead of constructing a rule and checking if it is in the set, I iterate over all of the rules to see if it is a relevant one. If it is a rule that says that the subject is something, then if I want to know if something is you, then I only care about the cases where the adjective is you. So that's the list comprehension notation for filtering. And then I call stack has subject, which does all the work. And of course, like the thing is you if there is at least one rule that says so. So that's why it's an or here. Okay, so stack has subject, which, as I said, does all of the work. It is parameterized both by the location, which again, so far, we've only seen on top, but we're about to see why I need anywhere as well. And that is because if I want to know if name on subject is on top of the stack which begins with entity, then I need to know both that entity is that name, using his name. It's not equals equals, because if I have a text and like a piece of text like the word is, then it's not equal to the name text, but the name text does describe it, because the name text describes all of the words. Whereas other names, like the name Giggle, describes a single object, a single entity, the Giggles object. Anyway, so yeah, I need to know that that entity is that name, and that this subject can be found somewhere in the rest of the stack, right? Because I said that the semantics I wanted was that if there is, I wanted that Sheets is on Giggles, if Giggles is somewhere in the rest of the stack. So that's why I need to be able to call stack and subject with anywhere. And if that's what I want to know, then I just ask about, like if I use tails again to look at all of the suffixes, if any of them is on top of a stack, that satisfies the constraint of the subject, because that subject could itself like recursively be something on something. So that was like fairly complicated. That was approach 1, which took me quite a while to even just explain. And I don't know if you've managed to follow it, but well, from the way in which I have explained it, I'm hoping that you agree with me that this is a complex-looking solution and an error-prone-looking solution, because, like I said, like you have to remember like which one you call, if it's bottom to top or top to bottom, and also because you have all those lists. Like we have a row that's already a list, and then within it, each element is a stack. Not sure if I want to draw it like this or like that. Not to draw it, but to pantomime it. So let's see, like this. So we have a stack in each of the cells. So that's another list. And sometimes I'm calling tails to get like sublist, all of the tails of that stack. It would be clear if I pantomimed it like that, all of the tails of the stack. And like it could, like we could easily forget a call to tails or something that just happens to be working, because like since those are all lists, like maybe I'm accidentally interpreting a list of entities in which for some reason I don't have stacks, maybe only interested on the things that are on top for some reason in that row, and now I'm interpreting an entire row. I'm sending it to a function that expects a single stack for a single cell, and it type checks, but it shouldn't. So that's why when I wrote this, I was not proud. I felt like there was definitely room for improvement, and that it would be easy to accidentally implement something incorrectly and to have a bug somewhere in there. And so I was not very confident that when I would run the program that it would work on the first try. And indeed, let's try to play. And it crashed, right? And it crashed not because I forgot a reverse, not because I called a function like I said, like a row. I had a row, but it expected a stack or something, but rather because I called head somewhere in the code on an empty list, which is usually like a dreaded error message for a Hascaller, because like it doesn't tell you where in the program you called head. Like maybe you called it like in hundreds of different places, and like how are you going to figure it out? But luckily, there's only 3 occurrences of head in my program, and they're all in level. And well, it would probably require like spending a bit of time in all 3 locations in order to figure out which one is the problem. But since I've already done the work, I can tell you that it's in this one, because I have this tails, which I already explained, right? It includes at the very end an empty list, which I told you would bite us. And here I'm filtering out those which are moving, I'm only keeping those which are not moving. So I'm calling the function, the functions that I've already showed you about, oh, is it you but not push or whatever, like that. There's some function like that to determine whether it is moving or not, because like even if it's you, maybe it can't move because it's blocked by something that's stuck. And whatever remains, I expect that for each of them it's going to be a list of the thing I care about and the rest, and I only care about the thing I care about, so I called head, and that's where it failed because this empty list was not filtered out, that there was nothing it could look at to know whether it was something that should be moving or not, and so it just defaulted to, I guess, no, it's not moving, there's nothing to move there. But since I am keeping those that are not moving, I'm keeping those which is moving, returning a false, then false was not a safe choice here. But true would not have been a safe choice either, because elsewhere I'm just doing the same filter but on those that are moving. So it's just the assumption that there is something that I care about followed by the rest. That is an incorrect assumption. Okay, so that was the first way of implementing the feature, which, as we just saw, it was buggy indeed. It was error-prone and it was buggy, but not like in the way that I expected. That was not one of the things I expected to cause a bug was not the thing that actually caused the bug we encountered, and it's fairly easy to fix. I just filter out the lists that are empty. List 2 maybe is like the version of safe head that is in base. Like if you have a list of more than one element, one or more element, it will return just of the first element, and if it's an empty list, it will return nothing. And then with map maybe, I discard all of the nothings, because overall I have a list that I've just filtered. So in the end, that gives me what I want. So that was an easy fix. So let's compare that with the other approach that I think is a lot more elegant. So how do I get there? Stack abstraction, great, this is where I wanted to be. So here is my new design. Like I wrote the bad design and then I went to sleep and then I had an epiphany and I need this abstraction that will make everything better. So I went back and implemented this okay, so this is the same entity as we've had before, and the same isName function that I've told you before. I just moved it to this otherwise new file. So I have 4 of those, like from top to bottom, from bottom to top, from top, 2 top to bottom, and 2 bottom to top. And can I get all the type signature of all 4? Not quite. So the idea is that stack, unlike the stack I had before, before I had type stack equal list of entity. Now this stack is a new type rather than a type synonym, and so this time if I want to act on it as a list, I need to explicitly say, do I want the version from top to bottom or the one from bottom to top? So I support both. So I thought that was much better. And like it goes in both directions, from and to, when constructing a stack and when examining a stack. Inside of it, the implementation of a stack is not just a list, it's a zip list, which is a new type around a list whose applicative instance takes 2 lists of the same length and zips them together. So that I can write operations like if I have a stack of int and another stack of int, and I want to produce a stack of int. then I can like add pairwise the ints together, the ints at the same position, using applicative syntax. So brackety dollar, brackety star. Right, so that's the kind of things I can do with a zip list, and therefore with a stack, because I've derived the applicative instance using generalized new type deriving. I've borrowed the applicative instance from that zip list. And the reason I want to do that is because, remember, I'm interested about things like, oh, is this entity push but not you, or something like that. And so my idea is that I want to have a stack of bools telling me, for example, like which of those are you, and which of, like a different stack of bool telling me which of those are push. So bool, 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 like you not push. How can I figure that out? If this one says which ones are U's and which ones are pushes, then I can look pointwise at those that are U and not push. Like this. So it's quite easy to express the kind of checks that I want to perform without hard coding, like I did with the previous approach, a bunch of functions that do that and only that. Like applicative is like very general, it allows you to compute easily that kind of thing and more. Okay, so that's why I used this definition. And I'm providing in this module like all of the functions that are allowed to look inside of the stack abstraction. Like I should probably like not export the stack constructor, or call it private stack or unsafe stack or something like that, so that it's clear that it's not meant to be called from outside this module. And the functions that I did define from inside this module are all things that pertain to selections, because that seems to be the thing that we want to do with those stacks. We want to know which ones are you, that's a selection, that's a subset of them, and which ones are not push, so push is a selection, and I can map not over this stack of booleans to get the opposite selection, if those were selected, and now these are selected, or something like that. Or rather, like all the space in between my fingers plus those. Okay, so I have a couple of helpers for selecting everything and selecting nothing, selecting all the entities that are of a particular name, so all the giggles in the stack, or all the pieces of text in the stack. And in order to implement whether something is on top of something else, select below less than or equal, and now since I can't use from top to bottom, I'll have to use like the unsafe stack constructor I mentioned, but I just need the stack, and I did export the constructor, so I can cheat here by using stack of list of a list from top to bottom, say false, false, true, false, true, false. And what this will give, if I import control.applicative, okay. A good trick, if there's no show instance, you can always use call force from GCI. Yeah, I had false, false, true, something, 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 and so now the result is false, false, true, 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 true. So everything else after the first true is true, and that's including the first true in the case of LEQ, less than or equal, but not including the first true in the case of LT, strictly less than. So if I force x and y on next to each other, you can see that this one has one fewer true. So that's what those functions are doing. And that is obviously used in order to compute the things that are below something, in order to compute the sheets on Giggles is you. Rule. Where was I? Select below. And then there are a few functions for if you do have a selection that is a stack of booleans, and you have like a stack of something else, and again I hard-coded it to entity because I thought that was the only case in which it would be used in practice, and I wanted to guide the user towards correct usage. Then I can trim down the stack to only keep those that have been selected, those for which the boolean is true. Or remove all of those for which the boolean is true. Because remember, right, I in the code, the line of code that had the bug, I was filtering out the things that were moving. So sometimes I care about the things that are selected, sometimes I care about the things that are not selected. And I can ask whether my stack of booleans is selecting anything or not. So I think that's a rather nice API, and then I was able to use it, well, I guess maybe showing it in the diff, log p, I think, will show me the diff between the previous one and this one, will show me like what I did have to write in order to use this abstraction, and I hope you agree that the code is now much clearer. So that's the line that was causing us trouble earlier. It was also very long, and now it's just drop selection. Because instead of asking for a function that looks at each entity and decides whether it's moving or not, I now just ask for a selection. Just tell me which ones are moving. Which I think is a nice abstraction as well. So I guess we have two abstractions. We have the stack and the selection. No longer using the on top or anywhere distinction, nor that stack as subject code. Instead, I'm calling it select subject. And I no longer care about whether it's on top or in the middle. I just provide, I compute a stack bool of all of the places in the stack where that subject can be found. I feel like that's a simpler concept than asking if the subject can be found anywhere inside of stack or can be found on the top of the stack. I just select all of them. But other than that, like the internal logic is a bit similar. If I want to select a name, then I select the name. And if I want to select a subject that is name on something, then we do the thing I told you before. No, I showed you about if I want something that is you and not push. So here it's like very similar. The combination function is and. I'm checking if there is the subject in the stack, and if the name that I'm looking for, well, I'm not checking if it's on top because I'm finding all of the instances. So I'm first selecting all of those instances and then selecting everything below it, so that in effect I'm filtering down the occurrences of the subject on which I must be that are selected by this recursive call to select subject. So I think that's also well, it's simpler code. Do you think that it's more obviously correct? That might be a hint. We'll see in a moment. And select adjective, again very similar to the code from before, where I'm iterating over all of the rules, and if it's a rule about the given adjective, I check if the subject that is that adjective, I select all of its occurrences on the stack. And I should probably explain the sequence. So I'm using the list comprehension notation, so I have a list of, not subjects, a list of selections. There's a list of stacks of booleans, but I want a single stack of booleans, and so first I use sequence A to swap the two outermost constructors. Instead of a list of stack, I now have a stack of list of booleans, and then I can map in order to collapse down this list of booleans into a single booleans using AND, which is from a list of booleans to booleans, and which returns true if they're all true. So that's how I combine all of those booleans. And yeah, as before, I have those helpers for selecting all of the things that are push, and I can now express things like select non-push stop in the easy way I mentioned before. In fact, it looks even better. Instead of having a lambda function here, instead of lambda x, y, x and not y, I just have ampersand, and I pulled the not here. I think it's even more readable. Not sure why I didn't think of it while I was demonstrating how zip lists work. So that's pretty much what I want to tell you about this approach. I think that it was clear from my enthusiasm that I like this approach much better. And so when I ran the code, did I install it in the background? When I ran this version of the code, I was much more confident that when I would run it, that it would work on the first try. And so let's see whether that is the case. Last time, with the first error-prone approach, I tried to move and it immediately failed with a runtime exception. So what happens now if I try to move? Nothing happens. I'm clicking. I'm pressing the key. It's not moving. So how come there was a bug, despite the fact that I used this this abstraction that I think is much better? Well, I don't really have a philosophical reason for why. In fact, I was really expecting that I would not have any mistakes and that there would not be any bugs, and that I would just use that to promote nice algebraic design, and that that would be it. But what happened in practice is that there was a lot more bugs with that nicer version than with the not nice version, and I don't know why, but I think it would be disingenuous if I was not revealing the fact that the opposite happened. So that's why I'm walking you through all of my bugs. So the first bug is not in these files, it's in the rules files. So did you spot the bug? There are a few. So one of them is that here I said that I combined all of the selections with AND, but that's not right. If we have several rules, then we don't want all of the rules to say that sheets is you in order to allow for sheets to move. Like we could have sheets on Giggles is you, that makes sheets you, and we could also have like text is push, it has nothing to do with sheets or with being you, and so it should be an or, right? If any of the rules say that I should move, then I should move. Unfortunately, that makes things worse. So with the AND, we could quickly establish that we did not have a we were not that we were able to quickly establish that we were not able to move. Like I won't subject you to the debugging session I had to do in order to figure it out, but I use the same approaches I've demonstrated several times in previous episodes, in which I'm going, like I'm pasting the code if it's like in a where block in the GHCI, and otherwise just calling the function in order to like narrow down what is the pure function that is not returning the result that I expect. And the thing that I was surprised by was that I was asking if a cell that contained nothing contained any stops, and it said yes. And that was surprising. And that was because end of an empty list, there were 0 booleans in the list, is true. So yeah, they're all true. All 0 of them are true. So that's why I was trying to move and was saying, no, you can't move. There's something blocking you. But now with OR, it's actually worse. Because it's a bit more complicated to explain why, but in a zip list, I can try to demonstrate that. In the REPL. So when you have an applicative, right, you're trying to say that you have 2 structures that have the same shape, and you're combining both of them like element-wise. So you have a certain shape that is the same everywhere, and so it makes sense to say that this element corresponds to this element, and this element corresponds to this element, and so on. Because I have the same number of fingers on each hand. I have 5 things, boop, they match. Well, matching, that's the brackety star operator, like combining the things here with the things here to get a single value for each finger. But if I have something like a list in which, yeah, there is a correspondence, but there isn't like exactly 5, then I get a problem with pure. So when there is exactly 5, then like pure of true, for example, is just I have the value true on all 5 fingers, done. But if it's a list, then I need to be able to combine this pure value with any other list, like regardless of how long it is. So if I have control.applicative zip list of 1, 2, 3. So one thing I can do is to map plus 10 over all of the elements. Sure, let's give it type annotation so that it doesn't complain. And I get 11, 12, 13. And I can also express that using brackety star if I use pure of plus 10 brackety star zip list. I get the same result. And if you think about it, how can pure possibly be implemented? Like, how long is that list? Because it needs to have a plus 10 mapping to all 3 elements of this 3-element list. But if I was applying this pure plus 10 value, like it's a single value, if I was applying it to a zip list with like 100 value, it would need to have a value for all 100 positions. And so for this reason, pure of, well, plus 10, I won't be able to find the show instance because it's a function, but let's say pure of true of zip list true, not true, zip list bool. It's an infinite list, which is, well, it's cool that Haskell allows us to do that, but it's not cool if what I want to do is to call a function like OR on an infinite, well, okay, OR on an infinite list of true will return immediately, but AND on an infinite list of true will loop forever, like searching for a false that doesn't exist. And well, I guess since I just switched it back from AND to OR, I guess the case that happened is that I had an infinite list of false, and it was iterating true, and that's why when I'm trying to move, instead of not moving because it's blocked, in this new and improved version, now instead it's trying to compute forever whether the thing is, whether that empty cell whether it is top or not, it is just computing forever. So that's pretty sad. And like I said, I wasn't able to quit the program. So the way in which I fixed that, if I go in Giggles' U stack again, was in the way in which selects any and selects none are implemented. So instead of asking if any of this infinite number of booleans is true, now selects any as a slightly more complex type signature. Like essentially, I just have a boolean, a stack of boolean and a stack of entity, and I just know that my stack of entity is finite, and I just chop off the list of booleans at that length, and that's how I avoid the infinite computation. But I'm providing a slightly nicer API, I think, in which it basically looks like I'm applying this selection, which is just a function, to its argument, but I'm applying it in a way in which I crop the return list of boolean. Because it could be that if stack of entity is the empty list, then it's likely that this function applied to the empty list produces an infinite list of falses. And so I chop it to an empty list, and then OR of an empty list returns false immediately. That's how I fixed that problem. What's the next problem? I forget. Just move on to the next commit and read the commit message. Fix draw order. Okay, so that was when I ran the program. Like it worked fine. I was able to to do most of the examples I wanted, except that when I was trying to move myself such that Sheets was on top of Giggles, the opposite happened. Sheets slid underneath Giggles, and that was clearly because something was wrong, either in the way in which I was drawing the level, or in the way in which, when I was moving things on top of things, maybe I was accidentally moving them underneath things. Turns out it was the former. So that was an easy fix. I just called to bottom to top. But the fact that I had to experience the bug by playing the game and then fix it illustrates a flaw in my design, which is that, going back to stack, I gave it a foldable instance. I thought that was clever because that allowed me to call OR on a stack directly, because the type of, one moment, I need the browser with Google to show you the type of OR. I know what it is, I just want to show you. Oh, I can just do it from the REPL, can't I? Oh, it's already done. So it's not from a list of Boolean, but it's from any foldable to Boolean. And well, that's more general. It works in more cases. That sounds good in theory. But since here I specifically defined some explicit coercions from stack to list that must be called when you expect a list. Well, if now I have a function like OR, which in my head expects a list, but in actuality accepts any foldable, then if I forget to call map not from, but in this case it would be to top to bottom or to bottom to top in order to clarify which one I want. Then if I forget, then the compiler will not tell me that, oh, I have a stack, but I require a list, figure it out. Instead, it will just gladly use the foldable instance to use whatever internal order I've used, in this case, top to bottom. And as I've explained earlier, my drawing routine, as does my pretty print routine, relies on the fact that the order was previously bottom to top. So that's what caused the problem. In the problem here, that fold map also fold map takes any foldable, I think. Yeah, it takes any foldable here, and so it iterated and then concatenated all of the stacks. No, it iterated through the stack and then concatenated the resulting sprites in the opposite order than what it expected before. And that's not all. Like, there was just bug after bug after bug. That was very disappointing, given that I expected the elegant approach to be less error prone. But again, I want to be fully transparent and show you what actually happened. There was only one bug with one and tons of bugs in the other. What was the next bug though? Yeah, I removed error prone foldable instance in order to guarantee that I'm calling it everywhere. So I guess this is not like a flaw in the Haskell library design. It's a flaw in my design of stack. If I didn't want it to be treated automatically like a list-like things whenever possible, and I required explicit conversions, then I should not have made it foldable. Okay, next. So here is a case in which I have like a bunch of columns, like A is on B, and I have a rule that says that if A is on B, then it is U. So when I move east, I do expect the A to walk to the right and fall off the B and land here, but B on A does not, and so B is not moving to the right. I don't think I could actually build a level in which that is true, because the A on B is U sequence of words would always be parsed both as A on B is U and as B is U, but here I control the rules, so I can't. Anyway, so here, like, there's a bunch of A's that are all on top of a B, so that's why they all move off the BC column and are all on their stack on top of each other. And here there's both an A that is on top of a B indirectly with this A in between, and this A is also directly on top of the B, so both of them should move to the right, but not this A. And here, well, same thing for this A and this A, but not this A. But in addition to, there's this other rule about B on A on another A should be moving, and so this one is a B on top of A on top of another A, and this one also is a B on top of another A, which is indirectly on top of another A, whereas this B is only on top of one A. So that's why there's a couple of B's here that have moved towards the right. And without the fix in the commit I just moved away from, we had a different result. Earlier, I asked you if the select subject function was obviously correct, and it was incorrect. So I was checking if I was selecting the, okay, for example, sheets on Giggles is U. I would be selecting sheets, and then I would select everything below sheets, and I would end that with Giggles, and as a result, those Giggles would be considered U and would move, but sheets wouldn't. So it's like the opposite set of elements that are moving. And so the solution is just to do the opposite. Instead of a select below function, I wrote a select above function, where I'm first selecting Giggles, and then I'm selecting everything above it, and if I find a sheet somewhere on top of one of the Giggles, then this sheet is allowed to move. In the elegant implementation, it was very easy to express something that is both more complex than what I wanted and also different from what I wanted. The fact, like if I like with the poor implementation, there would be a delta in complexity of the code. Like I would be writing a lot of code in the wrong direction before I get there. Whereas in the elegant implementation, both the correct and the incorrect implementation are about as succinct. So I didn't have to stray very far in order to get an incorrect implementation. All right, so that was a much longer stream that I anticipated. But this being the final episode, right, I couldn't split in the middle and postpone for later. But yeah, thanks for listening. And I don't know when I will be back with another series, but I do know what the next series will be. So a while ago, I published a video series on the Pact publishing platform called Mastering Haskell Programming. And well, I was quite unhappy with the editing, but it was still moderately popular. And I said that the next time I would do something similar, that I would do it for free on YouTube, and like these streaming sessions are kind of it. But now something else happened since, which is that Pact informed me that despite it being popular for a while, it's no longer selling as good as they wanted, and so they pulled it off the store, which I don't mind that much because I was not proud of the quality of the editing. But they did allow me to reuse the material as long as I don't include Pact on the slides. I've just mentioned their name a lot, but not in connection to the content itself, just to tell you about the next series. I guess I'll try not to mention their name in the next season while I go over that material. But yeah, that would be what the next season will be about. I will go over the same material, but instead of being poorly edited slides, it will be me going over it live. I have no idea when it's going to be, but that's what I am planning for it to be. See you there eventually, and thank you for watching Giggles as you. See you eventually, fellow Mascolars. Ciao!